Okay, let's look at another example of gravitational and kinetic energy. So this is different than the first example where we're now looking at something moving downwards. This question says a car of mass 2,000 kilograms is initially at rest. It then rolls downhill as shown below, and firstly we have to calculate its initial gravitational potential energy. So we just use our potential energy equation. Mass is 2,000, gravity is 10, times 6 gives us 120,000 joules of potential energy. We are also told it's at rest at first, so at the start its kinetic energy is 0, which means that at the beginning it has a total energy of 120,000 joules, and that's important because that can't change. Okay. It then says calculate its kinetic energy at the bottom of the slope. Well, by the time the car gets down here, its potential energy is 0. Okay, because its height's 0. What we know, however, is that the total energy has to stay the same. So all the potential energy, all 120,000 joules of it, must have gone somewhere, and it's being converted. As long as there's no friction converting some of it into heat, it'll all get converted into kinetic energy. It then asks what is the velocity at the bottom of the slope. We can now use our kinetic energy equation to work that out. So just do 120,000 is equal to a half times 2,000 times v squared. So 120,000 equals 1,000 v squared. Divide through by the 1,000 gives us v squared. So 120 equals v squared square root of 120 will equal v. And that just gives us square root of 120 is 10.95 meters per second. It then asks us what is the distance required to stop the car if the brakes can apply a force of 4 kilonewtons. This is a tricky question because it's hard to see what we do here. However, what we know is if it's to stop, the kinetic energy has to go from being 120,000 down to 0. And we do that by applying the brakes and converting the kinetic energy into heat and maybe a little bit of sound. When we're converting one type of energy into another, that means we're doing work. So we can say that the work done here needs to be 120,000 joules. We know that the force we can apply is 4 kilonewtons, which is just 4,000 newtons, and we're trying to find a distance. Okay, so we're going to use our work done equation. So work done equals force times distance. 120,000 is equal to 4,000. D, divide both sides by 4,000, which gives us that the distance will be 30 meters. It's quite hard to spot questions involving work done because the question usually rarely says the word work done. But if you're looking at energies and you need a distance, that should lead you to that equation, because you know this equation involves an energy, the work done, and a distance here.